A self-bow or simple bow is a bow made from a single piece of wood. Extra materials such as horn knocks on the ends, or built-up handles, would normally be accepted as part of a self-bow. Some modern authorities would also accept a bow spliced together in the handle from two pieces of wood. Advantages and disadvantages compared to composite bows. An effective self-bow can be made from widely available local material in most inhabited parts of the world, with limited tools whose functions include chopping, shaving, and scraping. A day of work may be needed. Starting with a seasoned stave, a composite bow requires a week's work, starting with a much greater range of materials and skills. However, self-bows must be long, approximately the height of the archer if they are to allow a long draw, and they are less efficient in the specialized art of flight archery. Well-designed composite bows of high draw weight give higher arrow velocity, and the bow itself is shorter, at the weights more usual for modern amateurs. The greater density of horn and sinew compared to wood usually cancels any advantage of composite construction. For most practical non-mounted archery purposes, self-bows can perform as well as composite. The initial velocity is about the same for all types of bow, within certain limits. History. In many parts of the world including much of Africa, the Americas, Northern Europe, and Southern Asia, the great majority of traditional bows are self-bows. The first bow artifacts, the Stellmore and Holmegard artifacts of Northern Europe, are self-bows. The Stellmore bow was made from the heartwood of a Scots pine, while the oldest Holmegard bows were carved from small diameter elms. In primitive flight archery competitions, bows inspired by the design of the Holmegard bows perform very well because of their light, non-bending tips. Selecting wood. In most inhabited areas, common timbers can be made into high-quality self-bows. The pieces must be long enough, and the grain must be sufficiently straight. Denser timbers normally store energy better and can be made into narrower bows with less effort. High-quality yew allows for particularly narrow self-bows, such as the traditional European version of the longbow. The eastern woodlands tribes of North America used hickory. Tribes in parts of the Midwestern United States Osage orange. Native Americans of the West Coast used short, wide, recurved bows made of American Pacific yew. Brazilian rainforest tribes used palm wood, and many others. In Europe and North America, common woods such as maple, ash, elm, and oak make excellent flat bows, and are far easier to obtain than good quality yew. The fibers on the back of a self-bow must be, so far as possible, continuous. This may be achieved by using the outer, underbark surface of the tree as the back of the bow, or by the painstaking process of removing outer growth rings, or by making or following a cut or split surface which happens to have continuous grain. The density of timber correlates well with its ability to store energy as it is bent. Denser timbers can make narrower bows. The same design for less dense timbers results in the bow taking excessive set string follow, or even breaking. However, equally effective bows may be made from less dense timber by making them wider near the center. The mass of equivalent bows is closely similar whatever the density of wood. Approximately the same mass of wood is required whatever the density of the timber. The overall length of bending wood must be about 2.3 times the draw length. Narrow bows can bend in the handle. Wider bows must be narrow in the handle if they are to be practical, but the handle must be made thicker so as not to bend, and the complete bow will therefore tend to be longer. Self-bows may be of any side view profile. Moderate recurving can often be achieved with heat and force.